Welcome to my YouTube channel. Second engine or third engineer. Section, A main Maguneria A.1, Internal Combustion Engines. This section deals with diesel engines, both 2 and 4 strokes cycle, slow and high speed, both main and auxiliary type, and with natural suction or supercharged. These engines, which started to be used in the maritime field around the end of the first third of this century, have become increasingly widespread. However, especially since the 1974 oil crisis, practically all newly constructed ships are driven by internal combustion engines. This is due to the low fuel consumption of internal combustion engines in comparison with steam systems. This difference is even more noticeable when ships are sailing at reduced speeds, since, while in such engines, specific fuel consumption is maintained at a constant level within a great variety of speeds. In the steam plant, specific fuel consumption increases substantially as speed drops. The first distinction that is found in diesel engines for marine use is the presence of slow and fast engines, depending on the speed of revolution, with fast engines being of lower power than slow ones. Fast diesel engines generally rotate at around 1000 rpm, the range being from 500 to 1500 rpm. Slow engines usually turn at a rate slightly in excess of 100 rpm, although revolutions tend to be decreasing all the time. There are even ships with rotating speeds considerably lower than that figure, about 70 to 80 rpm. In this manner, propeller performance is substantially improved, even though there is the drawback of a greater diameter. In the intermediate range, these days, there is a very broad range of medium-speed engines with rotating speeds on the order of 200 to 500 revolutions per minute. A second distinction is the existence of 2 and 4 cycle engines. The former are used more frequently on slow-speed engines, while the latter are used on medium-speed engines. In all the above types, the trend is increasingly to incorporate forced air intake, which produces a substantial increase in performance. The components of the engines are basically the same for all the types.
Regardless of size, the most notable differences are the material of which they are constructed, the type of fuel used, diesel oil, fuel oil, the rotating speed and the size. Selection of an engine's type is based on the size of the engine room, the power and speed requirements, the power and the speed requirements, the tonnage of the ship and the class of traffic for which it will be used. The cross-section of a diesel engine, along with its components, is given in the following diagrams. Also included in this section are the elements and auxiliary systems of a diesel engine plant that are not common to the steam installation. These specific systems are external and internal cooling, external and internal lubrication, fuel, engine operation, and supercharging, as well as the external elements of the engine such as turning gear, governor and reduction gear. Following are some data and practical cases that will be useful on board ship. 1. Block and bed frame. A. The cylinder block is made of cast iron and does not admit welding, so that
the most effective system of repair, especially in the formation of cracks, is the cold repair method. In this system, the cast material is not heated, so that there are no expansions nor any change in the molecular structure of the material. B. The block cooling water circulates on the outside of the liner, bathing the inside of the block. Therefore, in removing a liner to respect the inside, it is appropriate to drain the block completely of water, thereby preventing water from dropping into the casing. C. When a piston is removed, the level of water in the cylinder block must be lowered to a few centimeters below the top level of the liner, and the water leader of the expansion tank must also be shut to prevent water from falling from the head when it is removed. 2. Cylinder. A. Cylinder lubrication has the plasmazy function of forming a film between liner and rings to prevent the escape of combustion gases and, at the same time, to reduce the friction between liner and zings, preventing them from getting hot and reducing the speed of wear. B. Cylinders are generally lubricated through a series of orifices at different heights and at various points in the liner. Oil is supplied by one or more pumps driven by the main engine, which pushes the oil through pipes of small diameter which discharge to the ports in the cylinder liner. 3. Liner and piston. A. The inside of the liner should be measured, without removing it from the cylinder, using a micrometer gauge that is at the same temperature as the liner. If possible, these measurements should be made at 3 different levels on the liner, measuring the diameter at that level in port starboard and bow stern directions. B. Lack of cooling inside the piston can cause cracks in the piston crown and other substantial damage. Under suitable conditions, carbon deposits can form inside the piston that will prevent the transmission of heat from the combustion chamber to the piston. 4. Rods and rings. A. In two-stroke cycle engines, to make a complete separations between the space inside the cylinder where combustion takes place and the engine crankcase, there is a piston rod stuffing box, which among other functions, prevents contamination of the scavenging air by the oils and gases from the engine crankcase. B. Piston rings can break due to knocking against the surfaces of the liner and the piston, or because of irregularities in the liner wall. Broken rings, even if not visibly broken, can be identified by the fact that they are darker in color and lack elasticity when pushed toward and inside of their grooves. C. The clearance between the ends of piston rings must be sufficient to permit heat expansion of the rings, since they work at a higher temperature than the liner. The play is checked by placing the ring at the bottom of the cylinder liner, since the liner generally does not suffer any wear in the area. D. To reduce friction and promote good lubrication between liner and piston rings. New rings are slightly beveled at the edges of their active friction surface, at an angle not exceeding 45 degrees. If used rings are to be reinstalled, it is necessary to bevel their edges first, since the bevel will have been lost through constant working. 5. Intake and exhaust valves. A. When there is a leak in an intake or exhaust valve, it is due to irregularities in the closing airon, ring and cone. If these irregularities are minor, valve and seat can be repaired on board using a lathe, with subsequent grinding of both parts together. 6. Bearings. A. When the engine is shut down after long trips, it is appropriate to check, among other things, the play of the big end bearings, also known as crankpin or bottom end bearing. To do this, the corresponding crankshaft is placed in its upper or lower position and the top clearance is checked on all big end bearings using thickness gauzes. If everything is correct, these measurements should match those of the last. B. The upper part of the bedframe bearings usually has a circular groove to distribute oil, leading the oil at the same time through ports in the crankshaft to the big end and small end bearings. Small end bearings are also known as crosshead pin bearings. C. In 3 metal bearings, if the radial or axial play, as indicated in the attached drawing, exceeds the limit recommended by the manufacturer of the engine, the bearings have to be replaced with new ones. These bearings are usually not repaired. 7. Bending. A. Bends in the crankshaft arms are an indication of the alignment condition of the bedframe and flywheel bearings. Changes in the distance between crank arms are measured by means of a defectometer, which is placed at an indicated point between the arms of the crankshaft. Readings are taken at 4 positions: TDC, ST, P and BDC. 8. Scavenging and exhausting. A. The air sucked in by TH turbo blowers in 2-stroke engines in discharge to genial scavenging manifold from which the air flows into the cylinder while the scavenging ports remain open. On the next ascending stroke, the piston closes the scavenging ports and compresses the air sucked in. B. Fire in the scavenging chamber may be caused by combustion of carbon deposits at the upper portion of the scavenging air manifolds due to gas leaks over an extended period or slow combustion in the cylinder caused by PUD injection. It may also be due to back pressure in the exhaust of a cylinder, returning the gases to the manifold through the scavenging chamber. C. If there is an obstruction in the exhaust, the turboblower, in the exhaust manifold, etc., a back pressure is produced that prevents the combustion chamber from being evacuated in the prescribed time. When the intake air enters 3-cylinder, there are still exhaust gases there, which heat the new air and cause a high exhaust temperature. 9. Crankcase. A. The oil mist detector in the crankcase is designed to analyze the concentration of gases in the crankcase. This concentration increases when there is a temperature rise due to lack of lubrication in any bearing. The equipment has an alarm that warns of dangerous oil accumulation levels, and engine speed is automatically reduced, thereby preventing a crankcase explosion. 10. Injectors. A. The injections are cooled by means of water or fuel, though at present cooling means of the fuel itself is more widely used. The abandonment of water cooling is due to the risk of corrosion both in the injector itself and in the adjacent areas of the inside of the cylinder, when there is loss of water tightness in the water area. At the same time, cooling with the fuel itself has the advantage of construction simplicity. B. The needle of the injector nozzle must fall gently into the nozzle needle holder case of its own weight, the nozzle itself being slightly tilted. Inserting it with a certain pressure would mean that the fit is too tight, which could cause the needle to seize. 11. Pump and injection system. A. The exhaust temperature of a diesel engine equipped with a Bosch-type injection pump can be adjusted by varying the volume injected. A larger volume of fuel injected causes a higher exhaust gas temperature, since more calories are generated in the combustion chamber. The opposite happens with a smaller volume. B. If a diesel engine with a one-piece injection pump has this pump mounted 180 degrees from its normal position with respect to the crankshaft centerline, the engine intake time can be made to coincide with the time of injection, so that the fuel will be injected when the intake valve is open, preventing fuel ignition. Therefore, special care must be taken when installing. C. In the installation of unmanned engine rooms, it is mandatory that the injection tubes be sheathed to prevent their possible breakage and the risk of the fire resulting therefrom while there are no personnel in the engine room. D. In the case of engines that burn heavy fuel oil and that are lined up for heavy fuel oil operation, it is essential to have steam pipes accompanying the fuel pipes in order to maintain the temperature of the fuel oil. 12. Starting and reversing system. A. The purpose of the starting air distributor is to introduce air in the upper part of the starting valves to permit them to open, so that they will let the starting air enter into cash cylinder. 13. Safety valves. A. The crankcase safety valve is designed to evacuate the gases when any problem causes excess pressure inside the casing, thereby preventing the risk of crankcase explosion. 14. Starting valves. A. The most effective way to check the gas tightness of the starting valves is to touch the air intake tube to the valve during normal engine operation. If there is any abnormal heating, this is an unequivocal sign of lack of tightness of the starting valve, because these valves must remain closed when the engine is running. B. The starting valves are supplied with compressed air through the starting air manifold. When this air reaches the valve at starting pressure, the valve opens, overcoming the force of the spring, and allowing air to enter the cylinder. 15. Combustion and ignition. A. The degree of compression is defined as the ratio between the volume occupied by the gases inside the cylinder when compression begins and when it ends. In the formula, V equals volume displaces by the piston. V equals volume at top dead center of piston. The degree of compression ratio, with B. G equals V plus V, V. Therefore, since V is constant if V decreases or increases, the increase in the degree of compression improves the heat output of the engines, though the materials of the engine and the characteristics of the fuels establish a limit to its growth. B. To regulate the combustion pressure in a cylinder of a diesel engine equipped with a single-piece pump, it is necessary to act on the injection advance. Since the injection time is constant, if injection is advanced, then when injection is advanced, then when injection is finished, the combustion chamber will have a smaller volume than required so that the bases will be at a higher pressure. 16. Supercharging. A. If supercharged engines burn heavy fuel, it is necessary to clean the engine and the other parts in contact with exhaust gases, since the dirt deposits on the turbine can cause a drop in the RPMs of the turboblower and, therefore, a lack of air in the engine. The flushing should be done at intervals or when a large amount of dirt is noticeable. To do so, distilled water is injected, at a pressure of approximately 2 to 3 kg per square centimeter, inside the gas area, for about 10 to 15 minutes. WIH the engine at slightly reduced speed. The dirty water accumulated during the flushing is continuously extracted through a drain located at the bottom of the gas casing. B. In order to prevent premature corrosion of the different components of the turboblower, due to the galvanic action of the cooling water, Xene anodes are placed at the water intake and outlet area and in the cooling chambers. 17. Cooling. A. The direction of cooling water circulation in an engine is always from bottom to top. Water enters the engine at the bottom, which is, in turn, the coldest part of the engine. Gradual heating promotes circulation by convection and, at the same time, prevents the very cold water from directly reaching the hottest parts of the engine where it could cause serious DMG through sudden cooling. B. At the present time, it is possible to recondition an engine liner with corrosion in the water chamber. This is done by using caustic surfacing materials, Belzone, Cordoban, etc. Special attention should be given to the condition of the area where the O-rings are seated. Checks that the jacket is watertight, because corrosion here would allow water to enter the crankcase and contaminate the oil. C. On all ships, it is positioned to cool the propulsion engine directly with the salt water pumps, in an emergency. When this situation arises, because of the damage to the fresh water cooling system, it is necessary to switch the valves and flanges that connect the saltwater system to the fresh water system of the engine. Discharge from the engine is done directly to the sea, changing the system valves as required. D. The makeup tank, expansion tank, for a closed-circuit fresh water cooling system of an engine automatically compensates for loss of water cooling system due to drain of leakage and cooling. In addition, it eliminates air pockets and provides for expansion during heating up periods. E. Putting additives into the fresh cooling water is designed primarily to prevent incrustation of the walls of the cooled areas, jackets, heads, etc., because these scales would greatly diminish the transmission of heat, which could cause DMG to the engine. 18. Lubrication. A. Before starting the engine, it is essential to check the oil storage tank of the main engine and compare the reading with the level reading at the time of the last shutdown. In this manner, one checks for possible contamination with cooling water, when the level increases, and at the same time, for possible losses from the crankcase or from a pipe, if the level has dropped. B. When the oil pump hooked up to the main engine is not supplying enough pressure to the circuit, the standby pump automatically again once the pressure has been re-established. This situation arises rather frequently during engine operation. C. Excessive oil losses in an engine installation are frequently caused by losses in the oil cooler, malfunctioning of the valve during the cleaning of the filter of the lubrication system, burning of oil during engine combustion. Losses also occur in a leaking pipework system, through the crankcase doors, maloperation of lub, oil purifier, clarifier and incorrect pumping of the various drain tanks. In all cases this loss is detected, as has been started, by an abnormal and constant drop in the level on the engine storage tank gauge. It is necessary to eliminate heat loss quickly, because the ship could stop due to a lack of lubricant on board. In addition, if the low oil pressure alarm should fail, DMG to the engine could be very serious. 19. Fuel system. When the engine's fuel system is being purged, the following measures should be taken. The low-pressure fuel pump must be in operation. Turn the engine. Keep the atmospheric or indicator cocks open. Proceeding cylinder by cylinder, depending on the order of firing of the engine, air or residual heavy fuel in the fuel circuit is eliminated, which will substantially facilitate initial starting of the engine. 20. Turning gear. A. Before hooking up the turning mechanism, it is necessary to make sure starting air is shut off, that the indicator cocks, drains, are open, and that engine engaged sign has been posted. Otherwise the engine could be started by a false maneuver with the turning gear engaged, causing DMG to the engine and injury to personnel. B. It is appropriate to turn the engine slowly during the half-hour preceding startup of the engine, putting heat on pump into action and circulating the cooling water through the water heater, in order to make sure the oil lubrication all points of the engine and that the engine temperature is closer to operating temperature. 21. Governors. A. The governor or speed regulator is the part of the engine that maintains the engine speed constant regardless of the engine load. B. The governor is mechanically activated through direct transmission off the engine. This transmission is from the distributor through the vertical shaft. C. The governor controls the injection pumps through a connection system generally consisting of mechanical linkage. If the connecting system breaks, the engine tends to race. To prevent this, the engine has overspeed safety systems. Some of these systems stop the engine by cutting off fuel, and others limit pump capacity, preventing them from increasing the fuel supply. 22. Diagrams. A. On occasions when an expanded diagram of an engine cylinder is obtained, the compression point is not marked with sufficient clarity. In order to determine it is necessary to get a bar or compression diagram with the injection pumps raised. 23. Control system. A. Automatic shutdown of the main engine always works on the fuel supply. It normally cuts the fuel by means of valves actuated either automatically or through solenoids. When automatic shutdown takes place, care must be taken before restarting, to prime the high-pressure fuel circuit. Elevation of the air temperature above ambient temperature favors the starting of an engine, since combustion is easier. Each manufacturer specifies the optimum temperature for the operation of each engine. However, heating or cooling of this air would be harmful to engine performance. Therefore, special care must be taken during starting, especially in cold areas, by seeking to warm both the intake air and the cooling water in the oil. 24. Reducing gear. A. The reducing gear on an engine absorbs power due to the meshing of its gears. Although the losses are small, there is a difference between the power of the engine and that of the output shaft. Despite this, the gain in overall performance of an installation with a reducing gear is usually positive, since efficiency lost in the reducer is recovered due to the fact the propeller turns at its optimum speed. B. In a reducing gear, the turning direction of the output shaft depends on two factors. The turning direction of the input. The number of reductions or stages of the reducing gear. With an even number of reduction, the direction of rotation of the output is the same as the input. With an uneven number of reductions, the desertion of turn at the output is contrary to that of the input.